Welcome to the show, a moon affair. This is a special show on the Chandrayaan 2 mission. ISRO's Bahubali GSLV Mark III rocket will be launched on the 15th of July. This will take the spacecraft Chandrayaan 2 to the moon. The 3.8-ton payload will be the heaviest that GSLV has ever had carried to the space. This spacecraft will consist of an orbiter that will go around the moon and a lander-rover combo that will land on the moon, and the rover will crawl out of the lander and roam around the moon. This is going to be a very, very important mission for ISRO. The lander is named Vikram on the Vikram Sarabhai, the father of the Indian space program, and the rover Pragyan. The rover will go around roughly 400 meters around the mothership, the lander. And this project is to study the moonquakes, the tenuous atmosphere of moon, and a lot more. Let's watch a small audio visual on this before we continue this discussion.
We are built to go to the moon. Capturing the imagination of millions of Indians. To explore a new world, a new home. Chandrayaan 2 is a 3-in-1 mission of ISRO. Born at the U.R. Rao Satellite Center in Bengaluru. In addition to me, the orbiter, are my other 2 family members, a lander, Vikram, and a rover, Pragyan. My creators spent years of hard work to prepare me and my family for a mission of potential discoveries and challenges.
We are all geared up for Chandrayaan 2. It opens up a new era of lunar exploration.
3, 2, 1, 0.
Our journey to the moon will be on GSLV Mark III, the mightiest rocket ever built by India. Enabled by a powerful cryogenic stage, GSLV Mark III will inject us into a highly elliptical orbit around the Earth. As we approach the vicinity of the moon, we will be captured by its gravity. While my family detaches from me to softly land on the moon, I will keep a constant vigil on them from the top.
Our plan is to explore the unexplored regions closer to the lunar south pole.
This mission will help us better understand the origin and evolution of the moon. There are many experiments we plan to conduct while dating the moon. This is the beginning to our quest to unravel the mysteries of the moon.
Today in our studios, we have Dr. Mylswamy Annadurai, who was the former project director of Chandrayaan 1 and also the program director of Mangalyaan, or Mars Orbiter mission. And also we have D. Raghunandan, who is from the Delhi Science Forum. In this show, we are going to discuss about the Chandrayaan 2 and also ISRO's deep space mission. Sir, we'll start with you from beginning. I mean, when you launched or when you are heading this program for Chandrayaan 1, we used the PSLV launcher. Yeah. Today, we are going to use the GSLV launcher. How different this is going to be?
Yeah, you look at here Chandrayaan 1 to Chandrayaan 2. Chandrayaan 1, we have gone a lunar orbiter. Orbiter was going around the moon for the remote sensing of the moon is concerned. We have a small system called 35 kg system, which are passively impacted on the moon. But now in the Chandrayaan 2, we have to softly land on the moon. That means it has to carry its own propellant so that the initial velocity of nearly 1 kilometer per second needs to be reduced when touching down the moon. And it has to carry nearly 30 kg of a rover, which will go around the moon. And it will have some meaningful instruments also. All put together, the mass is slightly more. And again, as an empirical formula, you can tell that whatever goes to the moon, That is to land on the moon from that orbit to there. Half of that will go as a fuel itself.
Okay.
Because to reduce the velocity, other thing. So that means the overall mass requirement which to be launched from here, it is nearly 3 times of what we have carried from the
Okay, so this time the
Chandrayaan.
payload is roughly 3 times that of Chandrayaan 1.
Yeah, correct. So then accordingly, definitely PSLV cannot do that job. So even the GSLV Mark II, which is a real workhorse for the, which can carry up to 2.5 ton, also not possible there. So that's why GSLV Mark III, which is slated for this launch. Though even all the mission profile will look like more or less similar to Chandrayaan 1, putting the initial orbit in around the Earth, and from there gradually the using the fuel will take. But still, the initial mass of the whole system being this heavy, definitely yes.
That's interesting. Now, Mr. Raghunandan, I mean, if you look at man mission to moon, I mean, people taking spacecraft or even human being, I mean, there was a lot of activities in 60s and 70s. Roughly around 72, the last Soviet spacecraft went to moon. After that, there was a huge lull for almost 14 years. Now, people call this a second honeymoon. There is a race to reach moon. Many countries are making attempt. Why this second honeymoon?
I think part of the answer lies in the first honeymoon itself. In the sense that the moon landing, the manned moon landing, was more of a ideological challenge and taken as such by the United States in order to establish its leadership in the space race with the Soviet Union, which till then the Soviet Union had been winning. And the United States wanted to do something that would establish it as the #1 country, and it knew that the Soviet Union was not investing that much in manned space exploration. The fact is that the scientific value of manned exploration, I think there is still a big question mark around it. And especially with technologies advancing the way they are today, what is it that a human being can do that robotic vessels cannot do? That still remains a big question. But today, I think particularly for the United States, the question has once again arisen. We have done all this in space. Now we seem to be languishing. So what new can we do to spur the imagination and re-establish leadership? And this is one idea. Let's go back to the moon.
Fine. Sir, let's come to this Chandrayaan 1 and Chandrayaan 2. I mean, in terms of its mission, what are the differences between Chandrayaan 1 and Chandrayaan 2? What new we are going to do with Chandrayaan 2?
Yeah, if you recall what we have done in Chandrayaan 1, though before Chandrayaan 1 mission, nearly 69 missions have gone to the moon from US or Russia, even the manned missions have gone there. Definitely the discovery of water molecules on the lunar surface made a big impact.
Okay.
And that made, to my knowledge, I think that is one of the reason why going back to the moon. Okay, whether there something unexplored, still it is that gaps are there. The water brings in, that is to be there. And as far as we are concerned, this discovery we have done from the remote sensing. Okay, we are good at remote sensing. Yes, and today our technology is very good enough. We have done it remote sensing. Whatever we are remote sensing, if we are able to do it in situ, to confirm whatever the findings are okay, and that point of view, it scientifically is a next level of doing. Okay. But while doing all this thing, technologically also, ISRO would like to do something else. So technologically, softly landing on the moon and doing an in situ analysis using the rover is another technological step. I think putting the things together, Chandrayaan 2 is a logical extension of what we have done Chandrayaan 1 for our own. And possibly in case later something happens in a bigger way in the lunar soil, definitely India can play a meaningful role towards that. This technology and the science instruments will help in a bigger way.
Very, very, very interesting. Now, Mr. Raghunandan, I mean, let's look at this, the history of ISRO. When ISRO was formed, I mean, there were a lot of criticism that we are also entering into the space race along with US and then Soviet Union. But then Vikram Sarabhai very clearly said that we are not into space for showing our strength. We are there so that the human beings, particularly India, will benefit. So, space for human benefit. That was the main slogan that he formulated. Do you think ISRO, by getting into this kind of mission, is deviating from its main role?
I don't think so. For two reasons, which I'll mention. One is it's correct that ISRO started and continues to have its main programs as having an applied intention with some direct benefit to people on Earth, particularly in India. That is correct. At the same time, India is an advancing nation, and we need to push the frontiers of science. And science, as you know, is not only about application. Science is about research and curiosity-driven investigations. And there's nothing that spurs the curiosity as much as what's happening outside of the Earth.
Okay.
And the moon being the closest heavenly body, it's natural that our attentions will go first to the moon. And it must be placed on record that the cost at which India does this, and their credit must go to ISRO, is that we have been able to do it at much smaller costs than most of the developed countries have done.
That's I think a very, very important point. At low cost, good science. So like coming to the science, I mean, we have chosen to go to the South Pole, which is technologically much more tricky.
Correct.
I mean, if you want to land on the equatorial regions of moon, maybe slightly less challenging.
Correct.
But why we want to take such a challenge and our first mission itself go to the South Pole?
Yeah, if you again you recall the history, our legacy remains similar. So even for the people who have gone to the moon is concerned, even initially they gone for equator, then only measured only very few. I think to my knowledge before Chandrayaan, only 1 or 2 missions only gone the polar orbit. And we made an attempt, first attempt itself go on the polar orbit. Such you are able to systematically mapping the moon's point of view, polar orbit helped there. So having done that, and definitely we have seen the resources point of view, because one is science, another one is beyond science application point if you look at here, the water if it is there, so permanently shadowed regions, water would have been collected.
Okay.
And that our mini even synthetic aperture radar mission of Chandrayaan 1 also showed possibly for a few meters of thick ice possible, water ice possible has been told there. So this want to confirm that in situ, definitely polar region, and that too near to the South Pole, and where the nearby the shadowed craters are available. So our extended mission from Chandrayaan 1 to Chandrayaan 2 point of view, I think going for the pole is definitely it is worthwhile. And yes, we are going to be the first in that also. We have to tell that resources on the pole is much better than going for the equator. So that way I think it's one is logical extension. Another one is, yes, fingers crossed, I think we expect a better discovery to confirming what we have done Chandrayaan 1 much better way. That way it's a more logical to go for this. Even though it's risky, yes, we have to take a calculated risk.
So actually by landing on moon and also having a rover which can go around, you can establish what you have done through remote sensing, ground truthing, correct? Right? I mean, that's a benefit that we will get by actually soft landing on the moon.
Exactly.
See, Raghunandan, I mean, many people, or rather actually I should say that some people, particularly from Western countries, are criticizing India's effort into deep space. Like they're saying that we are getting into some kind of a race with China, very similar to what Soviet Union and US had. And they say that you are a developing country, you should be investing on development, not get into this kind of race. What do you think? Are we really in a race with China?
Yes and no. There is a competition. There's no denying that there is competition between India and China. And to that extent, yes, when India is going to the moon or going elsewhere, doing space exploration, then I think there is this part of this is the competition factor taking place. The second part of your question is that the cost and whether a developing country should be spending this much money. Frankly speaking, as a proportion, even within ISRO's budget, the curiosity-driven space exploration is a very small percentage of ISRO's total budget, most of which is in remote sensing, communication satellites, etc. If you compare this expenditure in space that India does compared to the expenditure that India has on, let's say, rural development, poverty alleviation. I don't think the space budget of ISRO comes even at the second or third decimal place of those. So in terms of what India spends to transform the country, to uplift the poor, to service the needs of the poor, there is no comparison between the amount of money India spends on that and the tiny fraction that India spends in space. In fact, the lament of most scientists and engineers in our country is we are not spending enough on science. And India till now is spending less than 1% on research and development, which if you compare us with, forget the developed countries which spend over 5% of GDP on research, even large developing countries or major developing countries, Malaysia, Taiwan, Hong Kong, these countries, China today is spending close to 5% of its GDP on R&D. So India is actually underspending on research when we should and could be spending more.
If you look at, let's say, a US spacecraft going to moon, perhaps it reaches moon in 3 days or 4 days from launch. But whereas we are going to take 50 long days, why do we need 50 long days to go to moon?
Yeah, I think typically look at here to reach the moon with the optimum energies point of view. If you are able to do a direct mission towards the moon, I think 4 to 5 days possible because especially when the manned mission US was doing, they cannot afford to keep the man going around the earth in a space for longer time. So at the earliest you should complete their mission there. So that way they made big huge rockets they made. The huge rockets, one shot, were able to throw the spacecraft towards the moon. So that and major portion is acquiring, the proportion is being spent only acquiring the moon around the orbit or landing is concerned. But otherwise, throwing is concerned, is the big rocket we can do that. But unfortunately, we don't have. Our missions are basically, launch vehicles are driven for the application, not for the manned mission. So that it is a shorter duration not called for. So that's why we have our ingenious way of doing. Even with a modest PSLV, we are able to go to the moon. It is only our ingenious way of doing it here. And that is with the modest mission, we can do the mission. And another thing is, this gives us another opportunity to calibrate the instruments en route to the moon. The longer the day you are there, you can calibrate and you can see that you can go to redundant system corrections you can make. That is one of the reason, even though we got first mission, polar mission, they succeeded. So I think that's how we followed for Mangalyaan also. You look at here, there also, with the PSLV, we are able to go to Mars also. So that way, even the modest launch vehicle, we can go deep space missions, we can do it. We have done it for previously Chandrayaan 1 and Mangalyaan 1. And now similar thing it's happening for here also. One is we don't have a bigger mission. Second thing is, even if bigger mission would have been there, this particular option of going around the earth and calibrating the things will help there. And beyond that, Chandrayaan 1 go there and drop the moon impact probe. But now we have to look for an opportunity. When landing on the moon, we have to look for that place is having a sunlit for the nearly 15 days.
Let's let this clearly. I mean, what do you mean by when you say that point is sunlit for 15 days?
Yeah, that means you look at here, the moon, always one side of the moon is looking at the earth. It's the earth-like condition. But moon also goes around the earth. That means at the given time, the moon has a 14 days a daytime, 14 days a night time. Okay. And when all our instruments, which is sitting in the lunar rover as well as the thing, all are solar powered systems, and we don't have a nuclear power to be going down there. So that means only 14 days only they can survive in the lunar surface. So to do a meaningful experiment, and at the start of that 14 days period, we should land there. So that gives an opportunity. Not every month, only one opportunity you will get there. Okay, that's the thing. In case you miss it, you have to wait for one more month. Okay, so this is the condition sitting there. So putting these things together, Chandrayaan 1, October 22nd we launched. We reached on the moon November 14th. Okay, using our own. That means we used 4 weeks we spent there. 3 weeks we spent there. So now here, additional requirement also is coming there. The soft landing also, here moon impact probe within 27 minutes touches the moon. But here it departs and it has its own orbit around the moon. Then look for the particular place and land the place where the sunlight will be there subsequently 15 days. So that opportunity comes only once in a month. So you match all these things. this number of 55 days.
That's a kind of cushion
Yeah,
that you
cushion,
keep
cushion,
to
cushion,
go
yeah,
around.
yeah, exactly.
That's a very, very interesting thing, as we can very clearly see how curiosity-driven work also looks at, even if I don't have the powerful mission like US, you try to do with what you have. But then some people may ask such a question that after there are a lot of curiosity issues on Earth, let's say there is a climate change issue, there are issues of water scarcity, why don't we spend our research energy on that rather than studying the moon or planets? That's a kind of question that some people ask.
I don't think you can do good science by posing either or questions. When you are engaged in scientific research, you would like to do research on all things that interest you. You may prioritize some. There are a lot of things we want to study in science and want to explore here on Earth, but also to understand the universe. The universe is there. It's around us. We know very little about it. And the more we can learn about it, sure, we would like to, for variety of reasons, but sheer curiosity is one of them, because the vastness of the universe has always intrigued human beings. You would know, for example, that the earliest science which human beings practiced was astronomy. Why look at the moon and the stars and the things when you could have studied the rivers and the trees? Because humans were fascinated by what is out there. We studied what was furthest away from us. That's how human curiosity works. Again, I will reiterate, however, I think India is underspending on research, and within research we are underspending on curiosity-driven science.
Okay.
The more we do that, whether it is terrestrial or it is in space, the better. I'd just like to add one small thing with what was just said earlier. I think gradually the more work that we do in space, particularly on the moon, for example, we are going to find this payload issue a limitation. And because the amount of weight we can carry is limited, we will have to once again, just like we did with the GSLV series, because we couldn't carry communication satellites to the desired altitude with PSLV, we needed the GSLV. I think we will find that we need a heavier launch vehicle, and especially if ISRO is embarking on human launches, we are going to find that a constraint, and once again, we will need to invest more in order to achieve that.
That's, I think, a very interesting point. So now coming to this mission, the Pragyan, that is a rover which is going to go on the surface of moon. Will it be like a remote car that we sit on Earth in the command center in Bangalore, they will operate keys and then the rover will move? Will it be like that?
Yeah, a remote controlled car with some intelligence built in. I think that's something like that is being considered there. Now even look at the remote control car also, when the toys goes and sees an obstacle, it able to reverse back on its own. I think some of the cars already available there. I think something similar is required for that. Though it's remotely commanding there, is if it moves. After moving some time, afterwards you are not able to communicate. Okay, then rover understands, yes, for longer duration, I'm not having communication to the ground. So then it will automatically senses probably there will be, yes, gone out of the range and or some reason communication outage has come. It has to come back on its own. Similarly, it is predominantly driven by the solar power, I think, with a minimum backup for the battery. So in case wherever it goes, the shadow or its orientation goes away from the solar sun radiation point of view, it will readjust for its own. So like that, it will always keep itself power safe condition, and it will keep itself in the range so that we can communicate from there. So that sort of intelligence is built in there.
So which means that these things will automatically happen by the rover itself.
Yeah,
you don't really go and say that, oh, you are in shadow, move.
Yeah. But we will ask them to move. If you take a photo, ask them to move. Yes, it moves. But after moving, before next step it comes, something happens, it has gone beyond the range, through from the lander we are not able to communicate, or its own power is getting shadowed. So it will come back to its original position. From there, once again we can communicate, and its power also is safe. So that sort of things are built in there, so that even if you don't have a communication and by any chance it loses the power, it comes back in safe condition.
So that's why ISRO is calling this as artificial intelligence enabled rover, right?
It's intelligent enough to do that. So it artificially added that intelligence. So it's called artificial.
That's how that name sticks.
Yeah.
So coming to you, Raghunandan, I mean, in this past 50 years, ISRO has embarked on various missions. Suppose if we have not gone into space, what do you think would have been major hurdles, major setbacks that India would have faced?
Difficult to count the number of hurdles we would have faced. The extent of exploration and mapping that India has been able to do of natural resources, minerals, water, forests, crops, we have been able to do because of our space capabilities. Otherwise, we would have been like the colonial foresters and collectors were, physically walking around the countryside to see what is where and doing physical surveys. We have been able to do a lot more in shorter time because of remote sensing capabilities. Now you're using those remote sensing capabilities for land use mapping, for urban development planning, and a variety of other studies, which we wouldn't have been able to do. India was one of the first countries in the world to experiment with communication satellite for the purposes of education, and infotainment was seen as a big way of reaching people.
So we have very little time for the show. So a last word from Professor Annadurai, please.
Yeah.
One last comment from you.
Yeah, basically look at here, yes, though as Vikram Sarabhai has told, is meant for our own needs we made done here. The science and technology, how it can fill it up. First to industrial revolutions, we are not part of it. In the space era, definitely we can do it. I think majorly we have done it. The societal applications we have done it, and we are able to churning it out almost every month on satellite. We are able to churning it out, set of that satellite for all the purposes like remote sensing, communication, navigation, weather forecasting, and the science. So then another thing is, though the scientific community point of view, we gave this thing here, and these missions also we learn a good amount of things. Again, get back to the application. For example, the miniaturization of the payloads, instruments. So you look at here, though yes, overall mass point of view, the satellites is having a less mass, but still number of instruments are fairly good instrument. We are able to, our instrument engineers and scientists are able to make it fast. So all the put together, I think we are able to go hand in hand, and the science and application together, I think the space is doing a fairly good. I think probably these lessons can be taken for the other areas also, so that when we are talking about the Indian science programs, I think we can do a lot more taking the lessons from here.
Thank you, sir, for being in the show, and thank you, Raghunandan, for being in the show. We have had a very good conversation with Dr. Mylswamy Annadurai, who was a former director of Chandrayaan 1 mission and program coordinator for Mangalyaan mission, and Raghunandan, who is from Delhi Science Forum. Thank you. We have enjoyed the show.